मेरे पढ़ाई नहीं है तो एसटी ग्राफ कर देंगे Because see, I got 2 minutes over. I have somebody. See, how many over and they're still out. Now they're still out. Abhi bolo. I was just telling ma'am they're all nice kids. Oh. थोड़ा प्रेम कर रही थी चलो बाय बाय 10th वन का कौन सा ज्योग्राफी और इंग्लिश इधर से नेक्स्ट है ना पूरा इंग्लिश
So now linear momentum is given by product of mass into velocity SI unit. In the first class we saw it. SI unit of linear momentum will be given by SI unit of mass, which is K.
Oh, sorry.
What is linear momentum basically? I remember that question. And what about velocity? Meter per second. And if I ask for CGS unit, then I have to know. Sorry. So like calculator, I have put taken care. Why are you sweating and what did you do? All right. Yes, so CGS unit would be what? Is it 2 volt? Yes, or gram per second? Gram centimeter. Yes. Gram centimeter per second. Yeah. Tanya is having one important question which she thinks not accept this definition that linear momentum is given by product of mass into velocity. Okay. Other things, Tanya, why we use this thing is because this velocity, this mass into velocity. So for your water bottle, let's call this book itself. If this book is lying here. What is its momentum? Not state. What is its momentum? Mass into velocity. Velocity क्या है इसका? So mass into velocity क्या देगा? 0 in respect to कितना heavy book हो? Then we derive no velocity. Momentum 0 है. Now what will apply?
Force.
And if I apply force,
It will not.
what changes? Velocity changes. Okay? And I introduce this arrangement for this important thing where I am talking that force depending upon how much force I apply, velocity will change with that. Okay? So if you apply more force, there is more change in velocity, and overall you can say that there is more change in momentum of this body. Okay? So if there is one body of mass m, इसकी initial velocity क्या है? U है, and then you apply some force like we did here. Apply force. I definitely know in this case my initial velocity क्या था? 0 था. ठीक है? But initial velocity 0 नहीं होता. मान लो रंगीर तो इतना हंस रहा है. मान लो रंगीर was walking just running. You go from behind. Okay? You go from behind and not question, let's not make him fall. But then let's say he was moving, but then that speed was not enough. So what you do, you actually take a thread and try to pull him. And शुरू कैसे करेंगे? स्पीड बढ़ाना है. ग्रुप से पहले टाइप पड़ जाएगा. So the thing is now enough of this. What I'm trying to tell you, this is the initial velocity, and when you apply force, you will see change in its velocity. So there will be some change in velocity. So there will be some final velocity. So basically, यहाँ पे initial momentum कितना था? Momentum is represented by letter P. That write that as velocity. Yes, represented by letter P.
E is equal to NP.
Why did not taking M? Because you know M is used for mass. If they use mass again M, then confusion comes. They have what you said. Okay, so they are represented by letter P. So the initial momentum in this case is given by what? M into U. For this particular body, कितना था वो? 0. So initial momentum कितना था? Let's just call this for our scenario. PI was 0. And here, आपने force apply किया. This body started moving. Let's say it moved with the speed of 0.5 meter per second. ठीक है? So यहाँ से यहाँ जो है 0.5 meter cover किया. 1 second. So final velocity कितना है? 0.5. So final momentum कितना हो जाएगा? Final momentum is given by mass into final velocity. ठीक है? And इसका अगर mass 1 kg होता है, initial momentum. PI is initial momentum. This is initial momentum. TF is what? Final momentum. And for this case, this books move with 0.5 meter per second की speed. ठीक है? अब book का वजन कितना था? 1 kg. So 1 into 0.5 will be. What is it?
0.5.
1 into 0.5 how much? 1.5. What are you saying? 0.5.
1 plus 0.5, 1.5.
0.5. And multiplied by 1 is same, right?
Yeah, I thought it was
It's all right. ठीक है? So यहाँ पे what is the initial momentum? 0. What is the final momentum? 0.5. So due to applying force, I definitely see that momentum has what changed, right? ठीक है? So that is why we introduce a combination. So we actually what change in velocity, that is C, but change in velocity with respect to mass. Why mass? Because how much is this force? Let's say that I have applied 1 Newton force in this case. If I apply 1 Newton force on this book, 0.5 is the move wide speed. But if I am applying that 1 Newton force on Ranveer, will it create the same effect? No. Why? Mass is more. So I want some combination which talks about mass as well as velocity, and that combo I get by defining a quantity which talks about mass as well as velocity for that particular object, and that is why we come with a new definition and we name that term as momentum. Okay, and then still it is not acceptable, then don't go much into it. Just understand that क्या है momentum, क्या है mass into velocity. The more
I didn't understand it. What is linear momentum? Where did mass and velocity come?
that I have told you the whole purpose. Why did we take two things? Not just velocity, but directness of mass as well, because those two things are crucial when I want to know something with respect to force. So that is why I bring the quantity which tells me about mass of that object as well as velocity of that. So why do we need linear momentum?
Why do we have to want to like? Why do we use linear momentum? What is
We are coming to that. Okay, I'm actually planning to tell you that, but maybe I need to tell you in some other way. All right, no problem. Let's. It is linear momentum. क्या clear है?
Yeah.
Okay. What is linear momentum? Mass into velocity of that object. And if this body was moving with initial velocity mu, I apply some force, and then I see that its velocity changes, and this is the final velocity. Okay. So if I take one normal case, just some random numbers with the book setting, I see that initial momentum of this book was how much? 0, and final momentum of this book is how much? 0.5. So I clearly see there is change in momentum from 0 से कितना हो गया? 0.5 हो गया. So how much is the change? Change is given by final velocity, final momentum minus initial momentum. So change in momentum is given by यहाँ पे mu and mv है. So यहाँ पे final momentum क्या है? pf minus initial momentum क्या है? pi. I can write it as what is this? And this mv minus mu, that is m taken common, it becomes v minus u. ठीक है? That is change in momentum. ठीक है? इधर से इतना स्पीड जो चेंज हुआ है, काम किया था, ये भी समझ होता है how much time was given for all this thing? Did it happen in short span of time? Longer time was taken to achieve this speed, right? So for speed, how do we say? Rate of change of distance, right? So here change of momentum is this, and if I want to know at which rate it is changing, so rate of Let's just continue this over here. All right. So rate of change of momentum is given by change of momentum upon time. आपने यहीं पे देख लिया है चेंज इन मोमेंटम का वैल्यू क्या आ रहा है m d minus u upon time, राइट? अब मुझे बताइए d minus u upon time को हम क्या कहते हैं? एक्सेलरेशन, राइट? फाइनल वेलोसिटी माइनस इनिशियल वेलोसिटी अपॉन टाइम को बोलते हैं एक्सेलरेशन. So I will replace this whole thing with acceleration. So it becomes mass into acceleration. Is this clear? Is this clear? I am saying that rate change in momentum मैंने पहले निकाल दिया. Change in momentum is final minus initial momentum. I get this. But I need to finally change जो हुआ यहाँ से यहाँ तक चीजें कितने टाइम में हुआ? कितने टाइम में हुआ? या within 1 second में कितना टाइम लगा था ये change होने में? So this change in momentum happened in what time? That is why I come up with a new term which is rate of change of momentum. For that change of momentum upon time करना पड़ता है divided by time, and if I do that I get mass into acceleration. ठीक है?
KHR23 ना इधर बस.
This is what Newton's second law. For Newton's second law, we are first discussing linear momentum and then momentum के तीन चार चीजें पढ़ रहे हैं. अभी तक Newton's second law पे
KHR मीटर पर सेकंड में डॉट का मतलब मल्टीप्लाई है.
yes. If you are putting dot, that means that it is multiplication between these two quantities. Like slash means what? Division, right? That is how dot means multiplication. So first type linear momentum, and please always remember momentum formula is mass into velocity. Okay? And then we are just discussing that body is moving. Don't write this. This is just random values that we took. 0, 0.5. ये random हमने सब अपने understanding के लिए लिया हुआ है. क्या? Final moment. हाँ, this is important. This is initial momentum. This PI means initial momentum. And PF means final momentum.
That is yeah.
Final momentum.
Final.
Final initial momentum. Is it done? Yes.
एक मिनट.
You know what the beauty of physics?
No.
Physics.
Nothing.
No. Oh, history is really fascinating. It was really so. Yes. Sunday. All right, I'm so sorry for this. At least I'm not.
Very much entertaining.
Here I have to focus on kind of name for it. So that others are kind of yeah. That's right. Now the beauty of physics that I was trying to tell you, at least your job gets simplified. Now you see there are so many words: change in momentum, rate of change in momentum. Everything can be quickly said. इतने भी लंबे लंबे आपको चीजें बोलना short में बोल सकते using some short symbols. ठीक है? Like for momentum, what letter do we use? P. And this is what change in momentum final minus deletion. Okay, so for showing difference between two things, we use a symbol known as triangle, and triangle means delta, and delta actually represents difference between something, basically change, and what objects instead of writing this whole thing so big, I can also write it as delta P. Are you getting this?
Yes.
If this is done now, I will now bring in the most important thing which we were doing.
Delta represent difference.
Delta represents difference.
It is also used in chemistry.
What is period? Oh yeah,
Yeah.
of course.
But
Everywhere
we use.
yes. So now, what is the most important thing? Why are we doing this? Because of Newton's second law, and Newton's second law states, we saw that for creating this change, for creating this delta P is what? Change. और change कहाँ पे हमने किया है? Momentum of the body. change हुआ है, ठीक है? और ये change कितने time में हुआ है? It is given by delta T, जो हमने time दिया हुआ है, ठीक है? हमने पीछे देखा था, राइट? आपको क्या मिला था? रेट ऑफ चेंज ऑफ मोमेंटम क्या मिला था? तो डेल्टा पी बाय डेल्टा टी आपको क्या मिला था? एमए मिला था, राइट? आपको ये मिला था, राइट? सो कीप दिस इन माइंड, एंड वी आर कमिंग टू इंपॉर्टेंट न्यूटन सेकंड लॉ. बट वी सॉ फॉर क्रिएटिंग दिस, लेट मी फिनिश दिस, वेरी इंपॉर्टेंट. फॉर क्रिएटिंग दिस चेंज इन मोमेंटम, ये ऐसा ही सब हो गया था. हमने कुछ बहुत क्रूशियल किया था. क्या किया था हमने? The body was sitting there, right? What did I do to change its momentum? Yes. And if I want to increase the change momentum, हुआ था सिर्फ 0.5 हुआ था, right? अगर मुझे 0.5 की जगह 10 का change चाहिए था, difference was 10. So what will I do? Apply less force or more force? More force, right? So I see that to create more change in momentum, I need to apply more force, and less change in momentum, less force. Okay? So through this, Newton came with the most important second law, which states that this force is given by rate of change of momentum. आप जो force apply करते हो, उस पे depend करता है कि कितना momentum change हुआ है in the given time. So he came with this important expression, and with the help of this, since we already saw पीछे की delta P by delta T was actually what? MA. So you can also say that force is equal to MA. So we got this very important relation, but you don't write it together because Newton's second law is this. Newton's second law is this, and using this we get one important relation, because हमने पीछे ही देखा था delta P by delta T is nothing but mass into acceleration. Are you getting what I'm trying to say? Yes, ma'am.
डेल्टा पी बाय डेल्टा टी मास एक्सेलरेशन कैसा है वो मेरा डाउट.
अभी हमने
मैंने बहुत टाइम पहले
इसके पीछे हमने जो डेरिवेशन आपने बुक में लिखा है, रेट ऑफ मोमेंटम.
हाँ लिख लीजिए.
Rate of change of momentum is rate of change of momentum को क्या आता है? डेल्टा P by डेल्टा T होता है. Change of momentum को लिखा जाता है डेल्टा P, टाइम को लिखा जाता है. This is the same. Delta means change and delta P मतलब change of what?
Yes.
Yes. question will come. First law, a tendency of the body called inertia. Inertia कहाँ से deduce हुआ? Newton's first law. और Newton's second law से क्या मिला है हमें? Linear momentum. No, linear momentum हमने use किया है. हमें सबसे important force का relation मिला है. Force का relation with respect to linear momentum and time. And then through that we get a very important expression known as mass into acceleration. ठीक है? Now write the Newton's second law. Newton's second law. So if exam में आया है, state Newton's second law. You can't write this. You have to explain first, state the law in words, and you can keep this in your mind. Okay, delta P up divided by time. That means you have to the law का definition या तो law state कराना. So please write and understand why we are using words like that.
Newton's second law question type में.
Definition उसको नहीं बोलते हैं, हम उसे उसका statement बोलते हैं. Shall we? Newton's second law of motion. So what does it say? What is this thing? We just saw. This is change in momentum upon time. How do we say this? Rate of change of momentum. Remember, we call this as rate of change of momentum. So rate of change of momentum. Write the law. Rate of change of momentum. Momentum. The rate of change. The rate of change of momentum. अब क्वेश्चन आ रहा, आप इतना लिख लिया तो क्वेश्चन है, हमें पीछे ही देखा था डायरेक्टली प्रोपोर्शनल या इनवर्सली प्रोपोर्शनल. अगर फोर्स ज्यादा आता है तो रेट ऑफ चेंज ज्यादा था या कम था? और लेस फोर्स था डायरेक्टली प्रोपोर्शनल. एक चीज बढ़ रही है तो दूसरी भी बढ़ रही है और घट रही है तो दूसरी भी घट रही है. दैट मींस rate of change of momentum is directly proportional to
Force.
The force of time is directly proportional.
Momentum is
Not momentum. Rate of change of momentum. Please don't say momentum is directly proportional.
no minus 590.
Rate of change of momentum of a body is directly proportional. Rate of change of momentum of a body is directly proportional to the force applied. Yes, to the force applied on the. आपने पीछे body लिखा है, object लिखा है. Body. क्या मतलब ये? Body is the body. It is directly proportional to the force applied on that body. Applied on it. Applied on it. All right. Force applied. And it's what that body takes place. But this is important. And so आपको पता है कि change जो है वो ठीक है, but हमेशा since we are talking about force, we have to talk. आप जब when I was applying force, where did it move in the direction where the so write the next thing and the change in momentum. The change of momentum. नहीं बार-बार body and the change of momentum. The change in momentum happens in the direction. क्या यहाँ पे excuse का anything is main thing is it is taking place or it happens in which direction? In the direction of the force is applied. In the direction of the force applied. The direction of the force applied. Now the thing is, Now the thing is, now pay attention. Your textbook has, now see, there is a lot of complication in the text, in the way they have given it. I want to simplify it as much as I can. So you pay attention for this part. Where is the rest? So you see definition. You see the definition. What did we say? That this force is directly proportional. Okay, wait, let me just write it. This force is equal to MA. हमने देखा है because delta P by delta T is MA इसको रखते हैं. But हमने जो definition लिखा था ना, वहाँ पे actually हमें simply equal to सीधा नहीं आता because हमारा definition क्या था? That force, the rate of change of momentum delta P by delta T is directly proportional to force applied. Are you aware of this symbol for proportionality?
Yes.
You are aware?
Directly proportional.
So then you must be aware that when you want to remove this proportionality sign and make it into equal sign, if I want to do that, I have to introduce one constant. Are you aware of that part? No, ma'am.
What is the difference between the directly proportional sign and the
What is constant? What is constant? So, okay, I'm going to somewhat mathematics now. If you understand, it's great. Otherwise, then you don't remember it by knowledge. के तरीके से आप proportionality sign हटा दे तो क्या होता है? Constant introduce करना पड़ता है. Now you have already understood that there is direct proportionality between force and mass into change in momentum, whatever there is. So let's take one example. कोई दूसरा example लेते हैं. Let's say one chocolate is of you get
400 rupees.
10 rupees. In 4 rupees, you get 2 chocolates. How much? 2. Number of chocolates. In 10 rupees, how much will you get? 5. In 12 rupees, how much will you get? 6. Okay? So basically, see that as I'm increasing one quantity, the other quantity is also increasing. Same logic like here, when force is increasing, the rate of momentum was also increasing. So that means this is also which proportionality? Direct proportionality. So if I write this is what cost and this is what number, if I write it like this, then I can say C is directly proportional to N. Can I write it like this?
Yeah.
But if I want to remove this and give relation, then what will I do? I will write C is equal to, I can't write C is equal to N. Can is C is equal to 4 is equal to 2? ऐसा हो सकता है? No. तो मुझे क्या करना पड़ता है? Constant value introduce करनी पड़ती है. आपने यहाँ पे देख लिया है, वो constant value क्या है? तो because 2 is what? Rate of C chocolate, right? आप लोग समझ ही आ गया था यहाँ पे. So आपको 2 number जो है, जो 2 है, constant number है, कभी change करोगे? इसीलिए सर constant of proportionality बोलते हैं, and these two things become n. Similarly, in this definition of yours, force is directly proportional to, like I'm not taking this काफी बड़ा दिख रहा है, एक छोटा सा लेते हैं, both are same, we know that, right? We just saw. So this is directly proportional, but then the rule was it was directly proportional, and आपको जब proportionality sign हटाना होता है, तो आपको वो कोई constant लगाना पड़ेगा. अब वहां पे तो मुझे समझ आ गया था कि it is 2. यहाँ पे I don't know, so I have to just let's say that number is given by K. Why not K? Why not K? So today we are taking K. In next chapter you will take G. In other chapter you will take C. It is up to you. Now since this is already published and जिन्होंने published है उन्होंने use कर लिया letter K. It is a constant here we just discussed. 2 is constant. You understood why you had to take it. So your force is equal to Kma, and we have arranged things in the sense physicists have arranged things such that K value is given as 1, and it makes your job very easy. That is why force is equal to Ma. मान लीजिए K की वैल्यू कुछ और होती है तो आपका फॉर्मूला इतना इजी नहीं दिखता ना. Force is equal to Ma. आपका force is equal to 2 Ma होता, 3 Ma होता या 3.5 Ma होता, बट K का कांस्टेंट का वैल्यू क्या लिया है? 1. ठीक है. यहाँ पे भी आप वही सोच सकते हैं बिकॉज आपने सेकंड लॉ जब कहा था तो इक्वल टू थोड़ी ना कहा था. आपने क्या कहा था? फोर्स इज डायरेक्टली प्रोपोर्शनल टू rate of change of momentum, and then you introduce that K, and since K is 1 only, that is why you can directly write this. So your textbook writes like this, and if it is writing, don't get confused. Why? This is also fine and this is also fine, because you have seen K की value क्या है 1. आप ऐसे लिख दो या ऐसे लिख दो, दोनों भी क्या है, because we are lucky K की value क्या है 1 ही है. अगर 2 3 4 कुछ होती तो ये गलत हो जाता. ठीक है, are you getting this point? Why introduce constant, ये भी समझ आया from that example hopefully. ठीक है, henceforth this trick, this proportionality and then removing, making it equal to, and then introducing constant of proportionality will be done in many chapters in higher grades as well. So you should understand, whenever you are replacing proportionality sign with equal to, you have to introduce constant of proportionality. So write in bracket, K is what? K is constant of proportionality. Just don't write K is constant. Which constant? Constant of proportionality.
Below Newton's second law of motion.
Yes, right. You can write F is equal directly proportional, or this is equal to delta P by delta. Whichever way, both also you write, that's fine. Do not get confused. That's my all request. I'm telling you these things not to confuse you, but to create clarity in your head. Why we are doing this? Okay, are we done?
Yes.
Clear? All right. So since we have done second law, we have understood why second law is important, because it tells you about force, and with the help of second law, we can now give a definition for force using this expression, that so many expressions that we got. Okay, now let's do that. Here after, let's do this. Can we take one question?
Yeah.
Using this given information, take one question there. How much force? You close your books now. Close your books. It's an easy question. All of us will be able to solve on their own. How much force is required? How much force is required? Question
I'm page number.
Nine. Close your books. I want you to write on your book. How much force is required to produce? And please write on your own. Okay. It's easy. I know each one of you can solve it. Answer is there on the board itself. Produce. How much force is required to produce an acceleration of what is the unit of acceleration, Shivesh? Used to put as meter seconds or meter per second. Meter per second. An acceleration of meter per second square.
Yes.
On a body of mass 0.5 kg. On a body of mass 0.5 kg. quickly बताइए कितना force आप लगाएंगे? 0.5 I said. Mass is 0.5 kg. And acceleration is 2 meter per second square. 2 meter per second square. Tell me how much is the force applied in this case? Which one? One. I also get one. Everybody is having one? Yes. Which formula did you use? Just one. Daniel, which formula did you use? Which formula did you use? Which formula did you use?
MA. F is equal to MA.
F is equal to MA.
You asked yes, ma'am. I said 0.5. Ma'am, there's like 2 point.
Alright, but the thing is, none of you told me what is the unit in this case.
Meter per
1 meter per second square.
kilogram dot meter second square.
Kilogram dot meter per second.
kg dot m.
Second, what is it?
Seconds.
None of you told.
Kilogram meter
per second. So unit of SI unit for mass is how much? Kg. And SI unit for acceleration is how much?
Meter per second.
Meter per second square.
I just did 2.5. Oh, no.
वो minus ना
What is minus?
इसके पहले minus आएगा ना S ऊपर का है ना
Minus meter per second square is talking.
But I
Slash
thought
नहीं रहेगा
meter
तो।
per if you are not putting
You write
slash,
if you write ms minus
Okay.
1 and m slash s.
can you tell me 1 kg 1 kg meter per second square? Okay. Now, if I tell you the other name of kg meter per second square, we have a short name. इतना भी इतना बड़ा बड़ा हो जाए तो दिक्कत होगी. And you know who is the one who has given us Newton second law?
Newton.
Sorry Newton.
Sorry. So Newton is the one who gave us this
Newton.
force relation. So the other name for this is Newton. So SI unit is Newton. So if you are not meter per second square, you can also write it as 1 Newton. Are you getting this point?
Yeah.
So 1 Newton is equal to 1 kg meter per second square. But that is very easy. SI unit तो आपको आसानी से आ गया kg meter per second square करके. अब मुझे आप बताइए CGS unit of force क्या होगा? CGS unit of force
GM point.
GM
dot
centimeter per second slash हाँ GM
Centimeter
point
per second square.
हाँ so यहाँ पे ग्राम क्या बन जाएगा GM जैसे ग्राम ही होगा G ग्राम ठीक है dot centimeter per second like above for this we gave Newton name for this the other name is Dyne. What is the name? Dyne. Are you getting the relation? SI unit of force. This is SI unit of force. Okay, don't ever tell me ये Newton acceleration का unit or something else. It is SI unit of force, Newton, and CGS unit of force is Dyne, and 1 dyne is what? 1 gram centimeter per second square, not per second. That's equal to Newton. What? This is equal to Newton.
It's equal to dyne.
How can 1 gram centimeter per second square be equal to 1 kg per meter per second?
ये ऐसा यूनिट हो सकती है
अच्छा आप लोगों ने ये वाला पार्ट लिख लिया राइट ये दिस पार्ट proposed ठीक है how much time do we have
10 minutes
7 minutes नहीं
35 को खत्म हुआ है 65
No problem. Now look at this statement to break. Sine is bigger unit Newton, the smaller unit is dyne. We know the SI unit for distance is what? And SI unit is meter. What is CGS unit? It's just the distance. It's the meter. Centimeter, right? So meter and centimeter are relations, right? 1 meter is equal to how much centimeter? 100. Right? We know this relation. Similarly, in 4 formulas, bada unit and chota unit will have some relation, right? And it's not necessary it is 100, it can be something else. We need to find that. So for force, we need to check for force. 1 Newton means how many dyne? This is what we need to find. So I don't know 1 Newton means how many dyne. I don't know that, but I surely know 1 Newton means
1 kg meter
1
per minute.
kg meter per second square. At least I know this. So 1 Newton, I can write it as 1 kg meter per second square. Can I write it like this?
G become
Ma'am, G or K.
kilometer.
ठीक है ना? Can you just cross check anything wrong? ऐसे भी लिख सकते हैं because हमने वहाँ पे ही देखा
नहीं ऐसे नहीं
क्यों?
लिख सकते मेरे को लगता है कि वो सब
But what is my purpose? Why? What is the purpose? I want this side to be in terms of dyne, and dyne is what CGS unit. So I will convert all of this into CGS form. Okay? So 1 kg in CGS form. 1 kg means how many grams? 1000 grams. So 1 kg means 1000 grams. 1 meter means how many
100
centimeters?
centimeters.
So into 100 centimeter. Second in CGS unit changes? No, the second remains second, so this remains second square only. So the answer I get is how many zeros are there overall?
5.
So 10 to the power 5. Can I write it like this? What is remaining? G centimeter per second square. But G centimeter per second square is nothing but what? Dyne. So that means I want the relation that 1 Newton is equal to 10 to the power 5 dyne. Is this clear? So आज के बाद अगर आपको कोई पूछे 1 meter means how many centimeter?
100 centimeter.
1 kg means how many gram? And 1 Newton means how many dyne? 10 to the power 5. अभी आपको हमेशा याद रखना है, जैसे आपको वो चीज दी थी तो याद है ना, अब से आपको ये भी याद रखना कि 1 Newton means दानिया, 1 Newton means how many Please note this, and I hope you have understood how to get this answer. Yes. Let's take few questions. आप दोनों ज़्यादा हो जाएगा और आप होमवर्क ले लीजिए.
वो देगा
Can you open page 48? The homework section. Copy of volume. Page 48. Homework question 1. Yes, homework question 1. Homework question 2.
Page number
48. Homework question 1, homework question 2. Homework, no, please get practice of numericals.
Question 1.
In 10th grade,
Question 2.
physics is all about numericals. 40% is numericals. If you do not get practice,
Oh my God.
question 3.
सब कुछ नहीं है
सब
बस ना इतने
ये 3 करिए और मैम 3 में भी 2 पार्ट मैम जो Apart from this, in next class, yes, ma'am, I'm just giving 3 questions.
Why not?
I
thought this would.
I am taking this very casually, but you are crossing the limits at times.
I'm not.
So if you will be in deep trouble, sometimes I lose my temper and we will have a discussion maybe with somebody else. Hopefully not the director and your parents. Yes. All right. So I'm just giving you 3 numericals. The other important stuff that I want you to remember is give me Newton's first law, learn it, and come Newton's second law, SI unit, CGS unit, and the relation. Okay, overall 3 numericals, 2 laws, and this relation. In next class, if okay, listen to the punishment today itself. If in next class any one of you is not able to show me the homework or not able to state the law, okay, you will be writing the homework, punishment homework 50 times, and if that is not done, we will be meeting director and your parents. Up to you. So I would request the first and second also. First and second also that. First one is easy. I believe you should be able to put it in words now. Second law will take some time. And the SI unit of force and CGS unit of force. Next week, right? We usually meet in 1 week. We are not meeting tomorrow. You have time. And it's not too much. It's up to you whether you want to do it 50 times or not do it and then we, or you can do it and finish it off in 1 word. Palash. Better. Okay. And apart from that, quickly we have time. We have 4-5 minutes. We can do some questions here. Why?
9 minutes actually need 25 periods.
Yes, not.
It's okay now.
No. You can solve very numerical things. Only one. You don't want to write. No. Oral. You don't want to write off. So next do one thing. Half of the homework we can do it right here. Learn both the laws. Okay. अभी मुझे बता दो बोल कर जाओ. ठीक है? ठीक है. Law. First line law. What is that? What you want the definition? How do you learn what to? We can put the law. It's not important words. What is your word? You can't make your own law, but physics.
Yeah, इतना ही बोली ना.
The right thing why is such a confusion. First line, if a body is in state of rest, it will remain in state of rest. And if it is in state of motion, it will remain in state of motion. In the same direction, with the same speed until an external force is applied. The second one is Newton's second law क्या है? Rate of change of momentum is directly proportional to the force applied on the body and the change दिखाई देगा in momentum that is in direction of the force. ये दो learn करें properly बोलिए in terms of words. आप words change कर नहीं सकते इसमें physics है इसमें. आप थोड़ा word change करोगे तो concept ही change हो जाएगा. Sorry. अब concept change कर तो नहीं चलेगा. I hope this topic, this is important. I got imagining
ये निकल सकते हैं.
I will backside so that Yes. Arjun. Can't give you extra chances. If you are on next person will start, then you will go back to your turn. After turns are like taking class, you will wait for others. If you are 100% confident, then you start. Give. Can you stop?